So up until this point, we've been talking about stop signals and go signals, or EPSPs and IPSPs. So write EPSP. Excitatory postsynaptic potential, EPSP. Excite. So it's an excitatory postsynaptic potential. IPSP is an inhibitory postsynaptic potential. To inhibit, to excite. So the go signal, or the yes signal, or the plus, or the 1, whatever you want to call it, is the EPSP. It's exciting. It's making more positive. It's making more likely to fire. Boom. To start that. Yeah, sure. It's making it more likely to start the generation of an action potential. So EPSP, excitatory postsynaptic potential. Now it's not, notice how it's potential, because it's not firing. It doesn't say, chemical signal is received, cell fires. You notice how it doesn't say that? You notice how it doesn't say effect, but it says potential? Do you see that? Do you get that? So it's affecting the cell. The signal that's received, the chemical signal that's received, affects the next cell by causing it to become more negative or more positive. So it affects its potential for starting a new action potential. Do you get that? It affects its ability, or affects the probability that it's going to start a new action potential. Do you get that? So if a postsynaptic cell receives a excitatory potential, if it receives a go signal, an EPSP, what's going to happen is over time, it's going to at that point become more likely to fire, to start an action potential, to send a signal to the next cell. Sure. So when the postsynaptic cell receives an EPSP, it just makes it more likely to fire an action potential, to initiate an action potential. Where is the action potential initiated, folks? At the where?
Is it inactive, you said?
It's in the where is it located? Where is the where is the trigger zone? The zone of summation. Where does the action potential start? Axon hillock. It's at the axon hillock, yeah. So that's the place where all these EPSPs and IPSPs are added up, that zone of summation. You see how I break down each concept in the kind of going very general to very specific? So now you get it? Okay, if you can't come up with that answer from me of axon hillock right away, you need to be reviewing your information more. You need to be making yourself note cards on Quizlet and reviewing them 10, 15 minutes a day throughout your day. You have to be on the subway, not in your car, please. No, don't study while you're driving. Don't listen to anything while you're driving, just drive. Okay, but if you're on the subway, if you're on the bus, not while you're transferring buses, but write these Quizlet notes down. Take notes, write them down, review them. When I say where does the action potential begin, you should know that right away. So it starts at, the EPSP and the IPSP is what the postsynaptic cell is going to receive. Which one is the go signal? EPSP is the go signal. Which one is the stop signal? IPSP is the stop signal. Very good. So what the EPSP most likely is these sodium gates open up, causing sodium to flood in to the cell and causing the inside of the cell to become more positive. So this is going to happen where? Where is this going to happen? Where is the cell going to receive signals from the other presynaptic cells? Where? No, the synaptic cleft is after the synaptic cleft. At what? By the way, I just heard a cell phone go off. Why? No cell phones. That wasn't here. Okay, but if it wasn't, then we'll have to go over to the next class and get on their case. Somebody go over and ask the next professor why. Okay. All right. So. Okay. So EPSP is when sodium. See, when a cell phone goes off, it just throws me off, guys, and especially for the test when we have an in-class exam. So EPSP is going to cause sodium to flood into the cell. What parts of the cell, what parts of the neuron can receive signals from other neurons? What parts? You should know this off the bat. The what? Dendrites and the what? The what? Big voices. What? Not receptors. Receptors don't exist here. The dendrites and the where. Where? We're talking the anatomical locations of the cell where signals can be received. The cell body, very good. The cell body and the dendrites, right. That's where signals can be received, at the cell body and the dendrites. Perfect. Okay, yes, there are going to be receptors on the cell body and the dendrites that are going to be specified for neurotransmitters, but the two physical locations that can receive signals from presynaptic neurons are the cell body and the dendrite. The only two places really that, well, that's not true, but the two main places where signals can be received from presynaptic neurons are the cell body and the dendrite. You see why it's so important to know the words presynaptic, postsynaptic, so we're not confused? Do you get that? It's just every word, every concept you have to know, because they all fit together into this puzzle piece. And if you were just given this puzzle and said, oh, here, figure it out, you could never do it. Every concept has to be broken down, has to be understood. And if you're missing a piece, you have to go back and go over it. So EPSPs happen when sodium channels open up, causing sodium to rush into either the dendrite or the cell body, causing it to become more positive. Okay, that's another phone. That's another phone. What's going on?